Hey there everyone, welcome back to my YouTube channel. So guys, this is video 11 of our machine learning playlist, and in this particular video we'll be covering the left out topics of data transformation. So this is the continuation video of my previous video. If you have not watched my previous video, check out that particular video. Link will be in this video description. And also those who all have not connected with me in LinkedIn, please feel free to connect with me on LinkedIn. If you have any queries, you can ask me on LinkedIn. I'll definitely reply you all. So the LinkedIn link will be in this video description. You can have a look on that. So guys, now let's not waste our time. Let's dive in my computer screen and discuss more about the data transformation. So guys, this is part 2 article. You can see here. With the help of this, I'll be explaining you all about the left out two topics, which is binning or discretization and binarization. So let's continue. So firstly, what is binning or discretization, and we'll see how to create or why we use it. With the coding implementation is also included. Then we'll go with binarization. Okay. So firstly, binning or discretization. Okay. Binning is the process of grouping a set of continuous or numerical points into a smaller number of discrete bins for analysis. So it's nothing but we'll be just grouping them. Okay, we'll be grouping them to a smaller amount of numbers for proper analysis. Okay. What are bins? Bins are intervals or range into which you divide the range among the continuous numerical data. So you will be dividing them, right? And you will be grouping them. Just understand, binning are nothing but you will be grouping the data and making a one bin so that you can perform the analysis properly. Okay. Why do we create binning? So, or bins? Simply for simplification. So data simplification we created, and handling non-linearity data. So if you create the bins, you can easily handle them, and dealing with outliers. For that also we use this. So we utilize the k-bin discretization library in sklearn for binning. Okay, so for that, let me show you all. I'll open the code out here. Let me connect. So I'll explain you all clearly with the help of code so that you can understand better. So import the libraries first: pandas, numpy, seaborn, matplotlib. So and from sklearn you are importing train test split, decision tree classifier. This is a classification model. We are using Titanic dataset only, right? So classification model, accuracy score and cross validation score, k-bin discretizer, and then column transformer. We'll be using all this. Okay. So consider those three columns are there for us. So we are using these three columns, okay, for this particular data set. And df.info, so we got the info of this particular data set. So you can see two of them are float and one is int. Survived is int. Okay. So drop now, we have dropped null values directly in this particular video. Okay. So we are dropping that. Checking the shape. So you can see here 714 rows are there and 3 columns are there. So first 4 rows we are checking out here. You can see here. And then what we are doing, we are just doing the x and y. We are creating the x and y variables, and we are creating the train test split. For train test split, we do that. So our x columns are age and fair, and survival is our target variable here also. Okay. So before binning, if we directly perform like training before binning, you see that the accuracy is of 62%. Okay. And even cross validation, if you see, you will see that your accuracy of 62% only. Cross validation only. So after binning, so you can see here, binning encode is equals to, we are using ordinal encoding. We are creating n bins is equals to 15. Strategy is equals to quantile. We are using quantile method here, okay. By using the quantile method, we are creating the age and fair binnings, creating the binnings. And what we are doing, we are applying column transformation here. First and second transformations, whatever it is there, right? We are applying column transformation. Now again transform the data, and we are again transforming it to xtrain and xtest. You can see here array. So now creating the data frame with before and after applying bins. So you will see the output. Okay. So output, if you see here, before applying binning, age was 32. Now it became to 9. 16 2. So we have created a bins. Okay. 18 2. So we have created a kind of bins so that it can stay properly. Okay. You can perform further analysis for that. Okay. Age label and even fair labels also you can see here. Okay. Now let us again perform training. You can see accuracy has been improved, but you will see a very little improvement. Okay, because you don't see a bit much improvement, but a very little improvement is there. Okay, so because the training data is very small, right? We have just 700 rows. You cannot expect more improvement in the accuracy. Okay. So now we are what we are going to do. We are plotting. We are plotting that age and fair before binning and after binning. Okay. So using discrete. Now you can see here age before binning. You can see here and after binning. You can see the data is a kind of properly distributed, and you can see that there is a difference between them. Okay. And even the quantile also. You can check the quantile of both. So you can see somewhat equally distributed. Now you cannot see like say like nominal distribution is there, but okay, you can perform some analysis with this quantile and uniform. Also, you can check the uniformity also. So you can see like after performing all this, you will see that there is a kind of little improvement after performing binning. So this will be helpful. This transformation is also helpful to us. Now let us go to binarization. Let me first explain you all about binarization. Binarization is the process of converting numerical data into binary form, typically into zeros and ones. This involves setting up the threshold value of any data point from threshold marked of 1. So while those are below are equal to the threshold mark of 0. So it is nothing but you will see that it is a kind of it will be everything will be in between 0 and 1 only. For that we use binarization. For this what we are doing, again we will be using the same Titanic data set only. So now we have considered this three columns and this both also. Patch and this also, this both also we have taken. Now we have dropped the null values. Siblings and spouse are there or not, or parents and child, or these both columns also we are taking. Okay. Now what we are doing, we are combining both sibling and that one, which is of patch, and we are getting a kind of created a thing called as family, because you can see here siblings means siblings or spouse or even parents or child, everything is a kind of same, right? So you can do one thing, you can combine both and create a column called family. So family is there or not, we have created into binary classification. So if family is there, 1; if it is not there, 0. That's all. Simple. Wherever it is 0 0, you can see 0 is there. Okay. Now what we have done, we have dropped survived also. From X and Y we took survived. Okay. So target variable is survived only. So X train data you can see here. Without binning, so first let us, sorry, without binarization, we'll run this. You will see the accuracy is of 62%, and even the NP dot mean cross validation is of 65%. Okay. So after binarization, so let us run this all. After binarization, we have performed some transformations, binarization transformation. So, and after this, you will see that the accuracy is of 61%. You can see the accuracy is dropping, but you can see the cross validation score is also dropped. So there is no much improvement, and it shows how, like, I'm just showing you all how you can implement binarization. You will see there is no much improvement in this particular data set. But when you have a large data set, you will definitely see the improvement. Okay. So you can see here before performing family before performing binarization and after performing binarization. This is the graph. Okay, it is between 0 and 1 only. So you can see there are only two bins created, categories. You can see categorical data. It has created into categorical data. So these both are also helpful to us. Binarization and binning are more helpful to us when we are training the data. But see, just understand whether it is feature transformation or else you can say there is this one binarization, binning, or even the column transformation, anything it is. So at the end of the day, you have to understand the data, and based on that particular data, you have to apply. You cannot expect like whichever you want, you can apply and you can get the results. Okay, so you can see there is something called as square and square root. You have to apply them only on right skewed and log transformation, and then reciprocal on left skewed data only. So there are some conditions which you have to understand when it comes to this transformations also. You need to know when to use which technique. So I have explained you all about this in detailly. Kindly just read all these topics again, once again, go through the articles and try to execute the code and see, make your own changes and try on your own data. You will get a better improvement and better accuracy on whatever you're performing. So guys, that's all for today's video. Do like, share and subscribe the channel. And this video is small among all the other videos. I know that. From next videos, we'll be seeing some more interesting topics. Okay. So thank you. Bye bye.